Hey there, everyone. Once again, we dive deep into our project. This time around, it's a finished AI project that is different various models and that build on what we were on the project we had started earlier. That is an events virtual tours model or models that recreate memories on events, culture, colors, ceremonies, to mention but a few, using different technology that is through different models. This time around, we based on a large vision models in the context of event promotion and engagement. So basically, previously we had seen, this is a project, a diffusion-based large vision models for contextual event promotion and engagement. So in this video, I'm going to be taking us through both a finished product and the back end of it all, and how we managed to come up with this whole product and all the stories behind it. So these are the keywords that is the large vision models, diffusion-based video generation, that is in relation to the model we used, and then event management, mobilization, and video enrichment, and AI storytelling and narration. These are my group mates or group members. So contents, because it goes deep from problem statements up to model selection and deployment, and all the tools we could have used along the way. Background. This couldn't be. We had already explained the background bit of it, whereby this project is meant to develop a large vision model-driven event management and participant mobilization system. And this system is now done. It has a UI already deployed on the cloud, and the model already on Hugging Face via Docker. So the methodology, we started by creating a data set which was literally small to train our model. So we had to retrain to go ahead and gather more data sets. Remember, we created a data set from scratch using past events, memories, and photos, and which we managed to gather at least 5,000 images. We went ahead and instead of data cleaning, we went ahead and created a metadata. So in this metadata, we have a CSV file containing of all the details of our images in the dataset plus their description. Since we realized that our stable diffusion model may, like, what we were working on didn't need, since we had created that data from scratch, we didn't need a lot of data cleaning. So what we could say, like our EDA to process our data, we had to make sure we create a CSV file explaining each and every image in our data set, and giving it a description. Since stable diffusion models, they interpret or generate images from prompts. So our model was meant to learn from these descriptions and in order to perform the way we wanted it to perform. So to take you back a little bit, so our domain application is in event management and experiences and marketing and advertising, so you can call it for the event sector. And in the input of our computation problem, we have a data set of images categorized in different classes, name it conferences, meetups, and workshops, and then it outputs an AI generated image. So like, and we have a UI chatbot that takes in prompts and to interact with our model and then generates images. So here we go with the accuracy and the quality of the images generated. One of the research questions that we'll dive deep into is that we wanted to see how a multimodal data curation framework can be designed to effectively represent diverse social culture and authentic and aesthetic elements of Ugandan and East African events and all events internationally at large for large vision model training, which we managed to achieve with our dataset we had created from scratch. And now our model can generate those images. And to what extent can a fusion of a pre-trained model, multimodal encoders, magically feed me etc. accurately capture and model the dynamic semantics of event experiences and including crowd interactions. So we have different types of models. We have a model that we created from scratch, and then we had to go for a pre-trained model that is the stable diffusion model with other models encoded in it, the two other models that work on pre-train, like they're already pre-trained, but we retrain them on the data, on our own personal data to get the results we wanted. And whereby, though our first model was not performing very well because of limited data, but right now it can easily get a panoramic view or event or a tour of a given venue of an event. So another question research would have been like, we wanted to see how effective are generative adversarial networks, we can call them GANs, in diffusion models in generally culture, authentic and contextually balanced synthetic data to improve LVMs and performance for localized event scenarios. So in this, our objectives, we came up to answer these questions, wanted to design and implement a scalable data curation pipeline for aggregating and annotating multimodal datasets for various events, enriching with social culture, and contextual metadata. Our product, you can say it's like software as a service, because once you have the API key layer, it has the UI already, which helps us interact with the model itself. So once you have the API key, you can integrate it within your system, already existing event management systems that are already existing there, so that it can be able to input that AI feature whereby it enhances already existing systems, and it be having that characteristic, it's already a scalable product, a product that already existing systems can integrate and have and become more efficient, let's say in event marketing and advertising. Number two was to architect and train a generative data argumentative model capable for producing culture coherent and balancing synthetic event model by enhancing large vision models and vast targets. As you can see, like they all relate to what I've already explained. I wanted to bring out something new, something that has not yet been made, but building on the knowledge of what is around, and which we managed to achieve, and integrated various AI concepts, generative and wake. Dataset previews, review, as I had already said. We created the dataset from scratch using past events images. So through this, since we didn't need a lot of EDA now used for our case, so we went straight from, after giving the module all the information it needed, the descriptions and the fully described dataset, CSV file, it went direct to training. In here, we were training the module, then starting training, like all to do what we wanted. And this, you can say, like, this is a sample of how our dataset looks like. Behind each and every image is described to help our pre-trained model, the stable diffusion model, to pick up so that it can generate images from normal English prompts. I've already explained this slide. Then model selection. And we used two of them, deployed them on cargo, then also on Hugging Face. Sorry, and my slides are not updated, but I promise to get updated slides. But we deployed it on Hugging Face. That is for the model. That is, if you want to interact with the model, you can interact with the model in two ways. That is through the the command line besides behind the IDE, the VS Code. Then you can also interact the model via our UI, which we created to help the user and the normal user who may not know what more of tech, they can interact with the model be like using our UI. So this is the mathematical formulation behind our model. This is it is more into a convolution neural network CNN, but of deeper learning and using huge amounts of data to come up with results. It encodes the convolution part of it of the constant xn, take y, then an x input, then into an k, and extract local features. And it encodes then the decoder output to the training. All this the mathematical simulation of our model. And so this is what our model can do. Previously, this was just a mere pre-trained data, and it was based on a few information, like on few data. It managed to come up with this image on the right. Yes, on the right. It wasn't not so good. So when we added more data, it managed to perform somehow well, getting the panoramic view of events of the events architecture. I mean of the events venue, and well more descriptive. And this is how our UI looks like. Like a user gets to interact with it by writing in prompts, and then it's generating the images as prompted. There's more of our model in training and validation of our evaluated model. So later brought up that. And in conclusion, I may take you through our already deployed model. Mm, to be splendid. So we deployed our model on Hugging Face. This is the copy of our model. This one wants to interact with it. And this is it, the event diffusion model, Hugging Face. And we tend to do via this link, one can interact. Now, on how to interact with our model, we managed to come up with a UI which helps users interact with our model, which is deployed. We deployed the UI face of our model on Brain Cloud by the help of Docker APIs, and I managed to come up with this. So in this, a user is supposed to type in a prompt. Mm, So after that, so after inputting here a prompt, this chatbot is expected to generate an image for you here, but just because I seem not to have the API layer link for this to input in this text field so that my chatbot can start working and generating as expected. So for the images generated here, the user can use them to do whatever they want. They can adjust it to the quality they want, the size, and then later download it here for what they need. So yeah, basically this is it, and this product is copyrighted to our group. So we have made it. So the image is meant to look like this. This is how it's supposed to be looking like. And then you can adjust it, then either download it. That is here I was testing it with a link. Now I need her to go back. I have to go back and integrate into our API and deploying the image. So yeah, thank you for listening.